I'm Lorraine Knockhand from the Rose Cutoff Middle School, and this is Danielle Lecoq from Lockport Middle School. And what we're going to do today is, first of all, let me talk to you a little bit about the MSP grant that we have been working on for 3 summers. The first summer was on the Common Curriculum, LCC, and we came back, me and Danielle were trained in Baton Rouge, and then we came back and we delivered to the teachers of Lafourche, the 8th grade math teachers of Lafourche and Assumption. Then the following year they had another grant, asked if we would do the Common Core, so we ended up doing that. Now this year they have another grant that they renewed, so but we're not going to deliver this one, we're going to be participants. So anyway, so we have been doing a lot with the Common Core and all, and today we're going to show you a couple of activities that are geared toward the Common Core and where it's going with rigor and relevance in the 8th grade mathematics. So we're going to start off with one activity that is a Common Core activity, and it's called the marble activity, and then the next one is going to be the leaf activity that we're going to do with using a graphing calculator. So we're going to go ahead and start on that right now.
This is called the Marble Lab. It was actually in the LCC, in the Algebra 1 LCC. When it originally came out, they actually moved it down to 8th grade, and they built up so much more on what was originally given, because they're trying to bring the rigorous down, and they're trying to get the students to be able to become critical thinkers. So there's lots of questions in here, there's lots of information here. This is your copy. This is not something you would give to the students. The students are going to be doing the actually hands-on, interactive lab itself, okay? Basically, I'm going to kind of just go through it with you. The first thing is the objective. The objective is to introduce students to the concept of slope as a rate of change. Students will add marbles to a glass of water and record the depth of the water. The change in the depth is a function of the number of marbles added. Since all of the marbles are the same size, the rate of change will be constant and the function will be a linear function. Now these marbles might not be exactly the same size because they might have some little discrepancies in them because they were manufactured and made in order. What I would do is if you do want it to make sure it's linear, make sure you measure them and make sure they're about the same size on each one of them. Like kind of hand pick them. We just kind of threw them in there today. It tells you what you need, the equipment you need to have a glass beaker or something that the kids can see through. You could use glass cups. What I've used in my classroom too is, you know how you can buy the mustard, the ketchup, and the at the dollar store. Even that you can use because you can see really good through it. And you can get like 3 for $1 or $2. It's really cheap. And those, they don't break. This, I'd be afraid the kids would drop it on the floor. So you can buy things that are plastic and they don't have to worry about them breaking. The instructions for filling the glass A and B, and they're giving you 2 scenarios as a teacher. You would not give this information to the students. You would want to kind of separate them, glass A and B. Some glasses you want to fill at a certain level. Other glasses you want to fill at a different level. So the ones that are these, I tried to fill them all at 150. The glass ones that don't have numbers on it, I tried to just make them all even. So that way they have 2 starting points of where they're going to start on the graph. Also, you want to have 2 different size marbles. Some students groups I would give the bigger marbles, whereas others might have the smaller marbles. So that way they can see how is the slope changing, depending on the size marble. Okay, and then the next is basically the procedures. This is what you would start with the kids. You would have them measure the depth of the water before any marbles are added. So the first thing I want you to do is using your ruler, you're going to use centimeters. You're going to measure the depth of the water in centimeters with no marbles in it.
Well, they'll start even, but if you hold it up, it's going to work.
Okay, after the students will measure the height of the water, the next thing you would want to explain to them is that if you have the smaller marbles, you're going to be adding 4 marbles at a time before you measure the water again. If you have the larger marbles, you're only going to be adding 1 marble at a time. You're going to collect 4 sets of data. So 4 times, you already have 1 set because you have without any marbles in it. Then you're going to collect 3 more sets. So you're going to add 4 marbles, record the data. What's the height of the water? You're going to add 4 more marbles, record the height of the water. And then you can do it again a 3rd time. Okay? Once you do all that, then just stop. We'll give you directions on where to go next. Okay, y'all all finished? Okay, I need somebody from each group to come stand up here with their graph. Okay, on the second page, these are some questions that you can ask the students. Hold it high so you can see it. Basically, you can ask them if the two of the lines begin at the same place, what does this indicate? If two of the lines, if you would have it all at the same level, and two of the lines begin the same, these kind of began about the same. Is that right? No, that's between, that's less. Okay, so if you would, you can say, what is the starting point? What does that mean? What does it mean?
That was the depth of the water.
That was the depth of the water. Okay, so if two of them would begin at the same place, it would tell you that they both had the same amount of water in their cup when they started with. If the two lines do not begin at the same place, what does it indicate?
So they all had different amounts
They all
of
have
water.
different amounts of water, and that's what we have here. How can you tell from the table that the data will graph as a line? How can you tell just from the table? What did you notice? They what?
They're increasing.
They're increasing at the same rate.
Right.
Okay, they're increasing at a constant rate. Okay, how can you tell from the graph or table which group had the larger marble? Looking at that, can you tell offhand which group had the larger marble?
Not necessarily, because everybody graphed at different intervals.
Correct.
Okay. Yeah. Okay. So you really can't tell from here. Which group did have the larger marbles?
I think we did.
Y'all did? Okay. So from here you can't tell. And the thing, when you do this, you might want to have all your students, you'd want to start at the same water level. You might even want to tell them what you want them to count by. And you might even all graph, like when we did this, we all graphed it on one paper. Okay? What we did today, and I didn't think about doing it with them because we could have did it with them. We had so many groups in here, like we had 11 or 12 groups. So it was no way we could put 11 or 12 lines in one graph. So we made everybody do their own. And when you teach it in your classroom, you do it with the students, you might all want them to plot it on one graph so they can actually look at how the line's changing onto one graph.
And they each use different colored markers so you can
Yes.
tell what group and what's their data.
Because you get maximum. You
Yeah.
know, who's the purple marker? You know, and let them talk about and discuss about it. If two of the lines have the same steepness, what does this indicate?
An increase at the same.
Same rate.
Same rate, okay. And if two groups have the same water levels and the same marble size, what would their graphs look like?
They should be identical.
Should be identical. That's
As long
right.
as it's at the same depth of the water.
Yes, as
They
long
have
as,
the
well,
same
that's
rate
what it
of
says.
change.
If they had the same water level and the same marble size, it should be the same line. If the table has information about the depth of the water of 8 marbles and 12 marbles, could you approximate the depth of 10 marbles?
Yes.
Yes. You can approximate where it would fall between just by looking at where it's at. Good. You can show the class a partial chart with information for 3, 4, and 5, and 6 marbles and ask, what was the depth of the water before any marbles were added? Okay, you can actually do that too. They also give you some terminology that you can use, bring in with the students. You want them to know what is the y-intercept. That was what?
Where it intercepts the y-axis.
Okay, what did it represent in this
Depth of
activity?
the water.
The depth of
At
the water.
beginning.
What is slope? What was slope in here?
The change
The rate.
as it went.
The rate of change as it
Right.
increased. Good. And that was basically how many marbles you were adding, right? They added 1 marble. Okay. Y'all were adding, both of those were adding 4 marbles at a time. Good. What is the independent variable?
Water.
Okay, does the water
The
get...
amount of marbles.
Yeah,
Does the water change the marble? Or the water?
The marble changes the water.
So the
Okay, so the independent is the one that stands alone is the marble. That doesn't change.
Always
What
your X.
change? What changes my water? So my water dependent on how many marbles were added. Good. All right, and then y'all can sit down. On this sheet, there's actually on the back, there's 3 extensions that you can add to this to actually, you know, extend the lesson even more. The first one is you can ask them to actually come up with the line of the graph. Okay? They can figure out what they need. I mean, my students at this point, teaching 8th grade, they know. When I tell them we're plotting a line, they know what am I looking for. I'm looking for the y-intercept and I'm looking for the rate of change. From those 2 things, you can tell me what the line is. So you can ask them to actually create the line. Extension 2, you can enter data from one group list into a calculator. You can take a graphic calculator. You can enter their information just like you entered it onto your chart. You can enter it into your calculator on this, and you can actually get them to plot it on a calculator. Then they can check their work before they actually even come up and show their answers to the class. So that's another extension that you can do. You can actually ask them some questions based upon that, and they have some examples here. Like, for example, what would the water level be if 43 marbles were added? Well, you wouldn't have enough to add, each group to add 43 marbles, because that would take a lot. But they can figure that they can add that number in their calculator, and it would tell them exactly what water level it would have to be. Or how about how many marbles are needed to make the water level 6.75 centimeters? Or how many marbles are needed to make the water rise 1.5 centimeters? Or how much does the water rise for every 20 marbles you add? So these are questions that you can extend by using a graphic calculator based upon just looking at a chart. They might not be able to figure it out. In the new Common Core that's coming down, there's a lot of technology with graphic calculators. I know in our parish, through our training through MSP, each school, middle school in LaFouche Parish, was purchased 16 graphic calculators to use in their to start us off this year in our with graphic calculators, so that way we can use them with our 8th graders, because there's a lot of technology coming down. Also in extension number 3, the repeat of this lab, you can actually do the lab again, and instead of, you picked it up because I'll just show you real quick. The water level, you started from the bottom here. You measured the water level here. Well, you can do the whole activity again, but this time, get them to measure how much water is not in the container. And then as they adding marbles to it, the water's going up. What's happening to the level that's not in the container? It's what's happening? It's decreasing. So then what's my slope going to look like? It's going down. So it's changing my whole slope from an increasing slope to a decreasing slope. And then you can talk about the difference of that. Why? Why is it changing? So those are just some extensions that you can do. There's even some thought-provoking questions on here. If the glass had been water, how would this affect the graph? If one group had a mixture of different sized marbles, how would this affect the graph? So you can even get them to write in this, because I know there's a lot of literacy strategies that are coming into each core next year, like with the Common Core. So these are some thought processes you can get them to actually write down. Okay, any questions?
And this activity incorporates also, you could go into a lot with the slope of the line, the y-intercept, you know, why is it the y-intercept, what does one of my coordinates have to be across the y-axis. So you can go into a lot of terminology using this one activity. Okay, the next activity is just a little activity using the graphing calculator. This one is on a reflection, which is one of the concepts this year that's a big issue on the LEAP is Pythagorean theorem and transformations. So this one is on a reflection. What you're going to do is you're going to take your leaf at your table and you're going to take your graph paper. You're going to use one quadrant only, the first quadrant. And you're going to put your stem of your leaf at the origin of your graph, at the first quadrant. You're going to start at the origin and you're going to trace it. After you trace your leaf, you're going to go all around and put points, ordered pairs around it so that you can graph it. Okay? So you're going to start tracing your leaf starting at the origin. And once you start, you need to have points going all the way around. Enough points that it will graph it. So right now, we need you to graph it, make your leaf, and then we're going to show you how to do the graphing calculator. And then you're going to list your ordered pairs. What ordered pairs are you using? You can have as many as you want. You want to have enough ordered pairs that when you put it in the calculator, it's going to define your leaf. If you leave some out, it might be a straight line right here, so you want to try and go all the way around, as many as you can. And then we're going to show you how to use the graphing calculator. Now, all the steps of the graphing calculator, it's like a packet. If you would like a packet of step-by-step, you can send me your email address, and mine is on the board, and I will send you a copy in free mail, because I know we all went with Fouche. So I will send you a packet. I didn't want to make so many being in such a big packet. I didn't know how many students we would have. So if you send me your email address, I will put it in free mail for you. Give you one per school, and you can go ahead and make copies.